Algebra 2, Chapter 3.2, Exercise 1 through 10. This section has to do with writing quadratic functions in vertex form, and it's a follow-up to the earlier video that kind of explains the whole concept and what goes on here. I'm going to do in this exercise set the odd number of problems and leave it to the viewer to complete the even number of problems. As always, I invite the viewer to work as far ahead as possible and then play ahead to see if you got it right. 1. A given parabola has an axis of symmetry of x equals 5, a range of 7 to infinity, and opens upward. What does this information tell you? You can use to write the equation of this quadratic function in vertex form. Well, what that means is just graphing this. We draw. We have x equals 5, 2, 3, 4, 5. And we have a range from 7 to infinity. So 1, 2, 3, 4, 5, 6, 7. What that means is we have a vertex, and by the way, here's our axis of symmetry at x equals 5. And we have a parabola that opens upward like this. And so what this means for vertex form is we have a function that has f of x equals, now we don't have a second point, so we have a, we don't know what a is, we know a is positive, times x, and here we have h is equal to 5, so we have x minus 5 squared, and then we're up, starting at 7 to infinity, so we put plus 7. So we have all we need for a quadratic function, except we need a second point to determine a. And if we're given that second point, we will be able to work out what a is. And that brings us to the next set. And these next 4 problems, 3, 4, 5, and 6, we're going to be able to use the concept here. Let's get that in place. Okay, vertex is 0, 0. So this means that h is equal to 0 and k is equal to 0. And we have our second point. So our quadratic function vertex form is going to be f of x is equal to a times x, only x minus h, which is x minus 0, squared, plus 0. And so now we can take this point 2, 8, and the 8 will go in the place of f of x, and the 2 will go in the place of x. And so we're just going to go below and write and solve for a, and we'll have it. So we put 8 equals a times x, which is 2, and 2 minus 0 is 2 squared, and we just have plus 0. So all we have to do is just solve for a at this point. So we have 8 on the left side, and 2 squared is 4, so 8 equals 4a. And if we divide by 2, we have the wrong thing. We got to divide by 4. So a is equal to 8 divided by 4, or 2. And so our equation of vertex form is going to be f of x is equal to a, which is 2, times x minus 0, 20 squared plus 0. And really, since these are 0, we could simplify this and just write this as f of x equals 2x squared if we wanted to. But purely in vertex form, this will be our correct answer here. Okay, next odd number problem, 5. We have a vertex at -6, 4, and we have our second point at -5, 0. We are notified that the parabola is opening downward. So let's just go ahead and write this. We have h is equal to -6, and k is equal to 4. So our function vertex form is going to be f of x equals a, which we don't know yet, times 20x minus -6 squared. And this is what we have to do. If we have h is negative, we have to make it x minus -6, and then we put here plus 4. And then now we have f of x is equal to a times x minus -6 is going to be x plus 6 squared plus 4. And now to solve for a, we're going to let's say x is equal to -6, f of x is equal to 4. Oops, but that's not right. We'll use our second point. We'll use x is equal to -5, f of x is equal to 0. So we go plug in 0 for f of x. 0 equals a times quantity. X is -5, so put -5 plus 6 squared plus 4 on the outside. Now we can just set about solving here. So just simplifying, we have 0 equals a times -5 plus 6 is 1. We have plus 4. And so we have, we can just start subtracting, start solving like 4. So we have -4 is equal to a. Is 1 squared. So that's it. And we're opening downward. So what is our equation? Well, we're going to have f of x equals a, which is -4, times 20x plus 6 squared plus 4. And this would give us our function vertex form. And just kind of to add on to suggest what this is, we have draw an xy coordinate plane. So we have a vertex at 1, 2, 3, 4, 5, 6, and then up 4. So here we are. So that's our vertex at -6, 4. And we have our axis of symmetry right here. X equals -6. And our second point is -5, 0. So here's our second point, -5, 0. And our parabola is going to look something like this. Okay, so if you graph this in a calculator, that's exactly what you're going to see. Now we go to this next set, in 7 through 10. Write the equation in vertex form of the parabola that has a given axis of symmetry, points, and direction of opening. And so we have an axis symmetry at x equals 3 and points 1, 9 and also 4, 3 and direction of opening upward. So we have a lot of room here, so I'm going to just sketch it here. We have XY coordinate plane. We have axis symmetry here at x equals 3. Here's our x is equal to 3. We have our points 1, 9. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1, 9. We're right up here. We have a point 1, 9. And also we have one at 4, 3. So we have 4, up 3, 1, 2, 3. So 4, 3. And we're opening upward. And so we have some kind of parabola that goes here. There's a vertex someplace along the axis symmetry. So that's what it's going to look like. So I'm going to start writing our equations we need to make this happen. So we're going to say we have our points here. 1, 9. We don't know. We have f of x equals a times x minus h squared plus k. And in this instance, the first one, we're going to have two equations. So our point is, our y value is 9, so 9 is equal to a, which we don't know, times x, and x is 1, minus h, which is 3, squared plus k. And so we can just simplify as far as we can. So 9 is equal to a, and 1 minus 3 is negative 2, and negative 2 squared is 4. So a times 4 plus k. So we have 9 equals 4a plus k. It's good that we have an equation, but that's not enough to figure out what a and k are to finish. So we're going to go to the right and use our second point here. And use our second point, we have 3 is equal to x minus h. So that's going to be 4 minus 3 squared plus k. And there's one more thing that I forgot to put in place. This is a. So a times 4 minus 3, 20 squared plus k. And so we have 3, and 4 minus 3 is 1. 1 squared is 1. So we just have a plus k. And so now between these two equations, we can solve to find out what a and k are. And I think the easiest at this point might be to just replace, we can replace anything. Let's just solve for k first. So if we solve for k, k is going to be equal to, we subtract a from each side, k is equal to 3 minus a. And so we can go and replace this k over here with 3 minus a. So we put 9 equals 4a plus, and I'm going to put parentheses here, 3 minus a. And what we have here is 9, and we have 4a minus a is 3a. So we have 3a, and we have this plus 3. And then if we subtract 3, we get 3a is equal to 9 minus 3, or 6. And so if we divide by 3, a is equal to 2. So that's one of the things we need. Now, we can take this 2 for a, and just plug it in right here. So we can say 3 equals 2 plus k, and subtracting 2 from both sides, we get k is equal to 1. So that means our equation is going to be f of x is equal to 2 times 20x minus h, which is minus 3, squared plus 1. So that's going to be our function. Okay, and that means our vertex would be 3, 1, so it'll be right, vertex will be right here. So our parabola when we graph it is going to look like this. Okay. And I'm going to go to the last problem we're looking at here. I'm going to do in the set. Yeah, the set includes through 10, but I'm going to stop here at 9. Again, I encourage the viewer to pause the video and then afterwards, after trying to work the problem, play it ahead to see if you got it right. So we have our x symmetry, x equals -3. So we take the standard form equation of f of x equals a times quantity x minus h squared plus k, and we're going to replace h with 3. So we have f of x equals a times x minus -3 squared plus k. And so that simplifies to f of x equals a times quantity x plus 3 squared plus k. And it says direction of opening upward. That means that we should expect to see a as a positive value. But we have two points. So we're going to I'm going to put here using the point -7, comma, -2. We're going to get -2 is equal to a times quantity, and x is -7, so we replace x with -7 plus 3 squared plus k. And going ahead to solve, we have find our equation, simplify. -7 plus 3 is -4. -4 squared is 16. So we have 16a plus k. So that's one of our equations. Now our other equations can be found using the coordinate pair -5, comma, -8. So we will say -8 is equal to a times -5 for x, and we're going to add 3, square it, and then on the outside put plus k. So we have -8 is equal to -5 plus 3 is -2, and -2 squared is 4. So -8 equals 4a plus k. So we're going to go ahead and solve this equation. What I'm going to do is take this equation here, I'm going to solve it a little differently than the last one. I'm going to take right this equation right below the other one. So we have negative 8 equals 4a plus k. And what I'm going to do to eliminate a variable here is subtract this equation on the bottom. So we're going to have on the left side of the equal sign negative 2 minus negative 8, which is going to end up as plus 6. And then we have 16a minus 4a, which is 12a. And then we have k minus k, which is 0. So we have 6 equals 12a. So if we divide by 12, a is equal to 1/2. And so now we can take this, we can take any equation we want to. If we substitute in this 1/2 here, we take negative 8. And now we're trying to solve for k. We have 4 times 1/2 plus k. So we have negative 8 is equal to 2 plus k. And solving for k, if we subtract 2, we have k is equal to negative 10. And so now we're ready to write our equation. We know a, we know k. So our final equation will be f of x is equal to 1/2 for a, and we have quantity x plus 3 squared minus 10. And what is this going to look like? It would look like this. We have our axis symmetry here. X equals negative 3. We have our vertex at negative 3, comma negative 10. We have our other points here at negative 7, 4, 5, 6, 7, comma negative 2. And also at negative 5, comma negative 8. Negative 5, comma negative 8. There we go, negative 5, comma negative 8. Over here we have negative 7, comma negative 2. So this is what our parabola looks like. Something like this. And so that's really it. I hope this has been helpful to you. Good luck, and thanks for viewing.